retrieval augmented generation, and businesses, this is a perfect match. And despite recent advancements in context window expansion, prediction of RAG's demise have been unfounded. In this video, I am introducing you to R2R, RAG to Riches, a great open source RAG engine that I found to be quite incredible. It seriously made life much easier for me as a developer to build, observe, and optimize RAG. You can think of R2R as the superbase for RAG, a complete platform that's bridging the gap between experimenting and deploying production-ready RAG application. It even supports open source models for your local RAG. The simplicity of R2R stems from its RESTful API, enabling quick deployment without delving into complex details. However, beyond all this, it boasts powerful features such as multimedia support, hybrid semantic and keyword search, then another advanced RAG technique called hypothetical document embedding or HYD, also automatic knowledge graph generation. So the core workflow of R2R is the following. Ingest files into your Postgres vector database, then search over ingested files, then create a RAG or retrieval augmented generation response, and perform basic user authentication. And also it lets you observe and analyze deployed RAG engine. And you get all of these both out of the box and also with a Python and JavaScript SDK. So you can fully integrate it with your own code base. And just like I was saying, R2R uses an advanced RAG technique called HYD, hypothetical document embedding. So let's quickly see what that is all about. So basically, traditional RAG systems have faced challenges in efficiently retrieving relevant information from large-scale databases. The primary issue lies in the discrepancy between query embeddings and document embeddings, often leading to suboptimal retrieval performance. So imagine your RAG system trying to find a needle, which represents a relevant info, in a haystack, which is your vector database. It asks a question, converts it into an embedding, and compares it to all the embeddings in the database using cosine similarity. This can be inaccurate, especially with large databases. And to deal with this, one very recent novel innovation that came in this space is HYD, or hypothetical document embedding. HYD flips the script. So instead of embedding the question, it generates a hypothetical answer and embeds that answer. This answer-focused embedding is much more likely to match the relevant chunks you are looking for. It's like having a magnet, which is the answer embedding that attracts the needle that is relevant chunks from the haystack. And R2R implements these HYD implementation very well. All right, here I am in the official documentation page of R2R. And the first thing I'm going to start with is installing R2R. And of course, you can go through all the section. There's very detailed, exhaustive documentation for each of the steps that you will need to install it and to initially starting and launching and doing some basic applications, integration, etc. And the easiest way to install it, just running this command, pip install R2R. That's what I did in my Ubuntu 22.04. And then start R2R with Docker. So it says that the following guide assumes that Docker has already been installed on your system. Refer to Docker documentation for installation help. So yeah, this is the best way and the recommended way to run initially with R2R, because with Docker you will have all the version etc. already taken care of for you. And so what I did is just go to your Docker official documentation page where you will find your installation instruction for various operating system. Right now I'm looking at install Docker desktop on Ubuntu. And you will also have instruction for Debian, Fedora, Arch, Windows, etc. Everything right here. Okay. And it's very easy. It will probably take just 2-3 minutes here. All you need to do is download this deb package. And after you download this deb package to your machine, then just follow the instruction. That is, you need to run these two commands or to just execute that deb package that you just downloaded. And after that, you need to launch Docker desktop. That you can do with this command. Everything is there. It's just a single page, very well written Docker documentation. It's super easy. And then you can actually start the Docker daemon by running this command sudo system control start Docker. Press enter. It will start Docker for you. And then you can actually check the status of the Docker by running this command sudo system control status Docker. And as you can see right here, active, that's what it is showing, right? Because I already have started it. All right, now coming back to the documentation, the next step you have to do is just running these two commands, and that's all. That is, set your OpenAI API key as one of your environment variable, and then run this command R2R -- config name equal to default serve -- docker. So basically what it's doing is that by setting the config name equal to default, it's using the OpenAI API key for your subsequent queries to the RAG system. And also by specifying the Docker tag, you are saying that you will be using Docker for this particular launch. All right, I'm back in my terminal and just going to run the Docker command. And let's see. This may cause issues starting the Docker. Yeah, I am okay with that. Yep, you see. So the Docker is running, starting Docker Compose setup. It for the first time, it may take maybe a couple of minutes because it has to download a few couple of hundreds of MBs, but that's okay. All right, I'm up and running on my local host right here, 8001 port. These R2R running RAG system. So all the tab you can see right above here, home, documents, chat, user, logs, analytics, everything is running perfectly. Now, another thing to note that because I logged in just a couple of hours before, so it did not give me the window where I have to enter my password and email, etc. for authorization. But for the first time, you will get it. So the point to note here is that the configuration of R2R is managed with a .toml file. That's what it says in the documentation. And when you install pip install R2R, then automatically a default R2R.toml file is created in the Python environment where your Python package is installed. But you can, of course, customize it when you are creating a custom projects, and there's details guideline for that. For example, here it says creating a custom configuration. Start by creating a new file named R2R my_r2r.toml in your project directory if you have not already done so. And then there you can mention all these things. Now let me show you this default R2R file that was created for me when I ran the pip install R2R command. And you can see here default admin email that's been set to admin@example.com, and also default admin password is set to change me immediately. So for the first time, when you launch this local host by running the command, then for the first time, you will be prompted to enter these admin email and default admin password, etc. And it will automatically have these input. You just press enter and go ahead. But of course, you are recommended to change it for any of your project. And to show you an example, I just reran my command, and this is the kind of window you will be initially greeted with. And as you can see, the password and email both are taken the default one. You just click sign in and then you enter. And otherwise, the TOML file has many configuration. All the important configurations are right here. Whatever you will change, you need to change here. For example, in my case, the model that I have selected, by default, it was selecting GPT-4o, but I reduced it to GPT-4o mini just to reduce my API cost because I was experimenting with quite a few documentation here. And again, you can change the base model here, which is by default, it's taking text embedding 3 small. And pretty much everything you can change. All your configuration control are right here. Now coming back to our running RAG system here in my local host. Let's upload some documentation, and just go to documentation tab, upload files, and there you can just drag and drop your file. So I'm just going to drop 2 markdown files here and upload. And yep, they got uploaded, and you also got the notification right here. Now I am going to ask question just like in a RAG system based on this documentation. So these knowledge bases, that is these 2 markdown files, has my paper summary of 2 recent LLM paper. So I'm just going to chat And you can see you are running in a RAG agent mode, and there's also a question answer mode. So anyway, let's run with RAG agent mode. So I want to ask, what is POA, or pre-training once for all? So the paper that I have summarized in the document that is in my knowledge base, that one of the paper has this particular concept. So it is the question that I'm asking, it is not exactly getting it from its training knowledge base. It is actually has to refer my knowledge base. Otherwise, it cannot answer this question. All right. Yep. So pre-training once for all is a novel self-supervised learning framework designed to address the challenges of pre-training models of multiple size simultaneously in a single training session. Yeah, that is exactly what it is. And this paper was recently released just like a couple of days back. So this is not from the model's knowledge base. It actually, sorry, it actually referred to the knowledge base and then answered your question. And I can further verify it right here. All these details that the answer has provided, that is actually referring to the document. So the tri-branch structure, teacher network, instant student network. Yeah, these are all by referring to the documents. Absolutely fantastic. Let's quickly go and check what are the other tabs around. So users, that is showing the user ID, number of files, total size. Logs will show my previous logs, analytics. Okay, because I have just done only one search, not much to show here. Otherwise, it should show you search, latency metrics, percentile, etc. And then the setting. This is where you will see the configuration of your entire RAG system. That is a model you are using, then KG extraction prompt, concurrency limit, etc. A lot of information here. So this is so fantastic because I'm running a RAG system right here in my local host, and I'm actually hitting the OpenAI API. And of course, for the model, you can also hit Anthropic, you can hit Together API. Quite a few of the API providers are supported. And of course, the local models, I'm going to show you an example, quick example of implementing the same thing with OLlama and Llama 3.1. So running with local models, there's also very good documentation. Just come to this section, local LLM RAG, and just follow a couple of commands that they are saying here. And also they have a good video by the founder of R2R. So you can just follow that. And actually the steps are exactly the same. Only thing is for running with local models, you have to change the Docker command to this. That is the config. Instead of default, you say local LLM. That's all. That's all the change you need. And otherwise, you need to install OLlama. So it says R2R supports RAG with local LLMs through the OLlama library. You may follow the instruction on their official website to install OLlama outside the R2R Docker. To include OLlama inside R2R Docker, pass the selection exclude OLlama equal to false in the command shown previously. So basically, it's of course better, I think, to install OLlama separately, but you also have the option to include OLlama right inside your R2R Docker. And just quickly go and check. The OLlama installation is actually super easy. Just download it and then run it. It will take only a couple of minutes. And also another quick point, before launching R2R in your local host with Docker, you need to launch your Docker desktop. So this is my Docker desktop in Ubuntu, and you can see all the images, everything is downloaded here. And what's fantastic is that when you run the pip install R2R and then launch with Docker, then all these extra libraries, everything is taken care of. You can see Neo4j, pgvector, etc. These are all taken care of, but you have to if you don't go the Docker way, you have to install the pgvector, Neo4j, etc. separately. And let's see the containers running. This is the container that is running R2R. And if you click here, you will see everything, all the things that you are doing here. All right, now coming back to running with local model, and in your local machine, just like I mentioned, install OLlama from the official page of OLlama, and then just need to run these three commands. And these are very standard commands that you run for running any model with OLlama. That is, you need to pull the respective model. Here, the example is for Llama 3.1. And then also you need to pull the embedding for our RAG system, because we have to vectorize the documents, our knowledge base, before we can do vector search on them. So here they are using this embedding model. Definitely you can use whatever model you prefer here, and then finally run Ollama serve. And the next thing you need to change while running with local models, that is the configuration in the TOML file. So as we mentioned, R2R uses TOML configuration file for managing settings, which you can read more about here. So for local setup, we will use the default local LLM configuration. This can be customized to your needs by setting up a standalone project. Okay, so obviously the model here is no more OpenAI GPT-4 model. Here it's a local model, so you specify the model name right here. And also you change your base model to whatever you are using here. Yeah, otherwise I don't see much changes. These are the only two changes that you have to do. All right, now the very important thing, that is looking at the Python and JS SDK of R2R. Because all these functions that we just saw right now in our local host, that was done on a GUI basis. That is, we uploaded documents here and then searched and did a chat on that document. But now we are going to do the same with the Python SDK programmatically. And they provide both Python SDK and also the JavaScript SDK. And the installation and the steps are very well written in the documentation. So I'm just going to follow exactly with the documentation. So the first thing you need in your Python file is importing this R2R client. So I'm just going to run these 3 Python lines one by one in my VS Code. So yeah, the first one is I'm importing, and the second one just initializing the client, and then the third one checking the health of the client, and the response okay means everything is just fine. And now I'm going to upload documentation to my running RAG. And so for that, I'm going to choose 2 of my local files. The name is script3 and script3 v2. Now going back to my running RAG system, we can see that currently we have only 2 documents. That is script and script2. Now we are going to upload 2 more documents from VS Code. And for that, again, I'm just following whatever script they have provided. Definitely, depending on your projects, you have full control over how you want to change it. And the script is just very simple. You just mention the file names, metadata, and then a client.ingest files, and then provide the file paths and the chunking configuration. Chunk size, max chunk size, chunk overlap, all these are configurable. So I'm just going to run that. And let's see. Yeah, everything looks fine. So when I print the ingest response, it says process document. So that these 2 documents are processed successfully. It says it clearly. So let's go back. And okay, there are also failed documents, skip documents. Yeah, so there is empty. So if there was some documents which could not be uploaded, then they will be showing up here. So let's go back and see, refresh it. Yep, everything is fantastic. So we can see that there are 2 more documents that were uploaded just now. These 2, script v3 and script3. Yep. All right, moving on, they have provided quite a few other things that you can do programmatically here. I'm just going to check a couple of more. So this is for updating the documentation. Again, you have to run these client.update files and provide the file path and the document ID. Yep. And you get the document ID by just running this method, document overview. Let's just run it. Yeah. So here you get all the details of your document. So I have 4 documents right here. So I have 4 document ID. Each of them is mentioned very clearly. So similarly, you can check the chunk of a particular document here in this line. I'm just printing the chunk of this particular document. And so this is how they are chunked, this particular one. And definitely, if you change the document ID, it will show you the results for other document. And the next I'm going to choose to run this line where I'm asking this same query. That is the exactly same query that we asked in the chat, in the GUI, in the web interface. Now I'm doing it programmatically here. Just run it. Yeah, that was quite fast. Let's see the answer. So the paper claims POA is the first pre-training paradigm that integrates unsupervised representation learning once for all. Exactly. That's exactly the same answer that we got in the web interface. And that's exactly the right answer. Fantastic. All right. So similarly, you can do lots of things and integrate it with your end user application to completely integrate a very powerful RAG system on whatever web application or mobile applications that you are building. And just coming back to this same page, you can do AI-powered search. You can you can search with custom settings, that is search with custom settings such as bespoke document filters and larger search limits. So here we with this parameter, you mention vector search settings, search filter, etc. Going further, you can do hybrid search, that is combine traditional keyword-based search with vector search. And you can also do knowledge graph search. So yeah, quite a few functionalities are there. Definitely go and check their documentation. You will get quite a few ideas here. And also check out this part of the documentation, very interesting one, web development. That is R2R gives developers configurable vector search and RAG right out of the box, as well as direct method calls instead of the client-server architecture seen throughout the docs. And this is an example of that. So here the example is about connecting your web app easily with R2R JavaScript client. And these JavaScript files just shows that. So you bring in the R2R client and then define all these client related object, etc. with your local host here, for example. And then also define all this constant email, password for authorization, and just go on with your business right here. That is, you ingest a set of files, which is what it's doing with await client.ingest file, this particular method. Then also use JSONify with your ingested file, and then just continue asking question, that is queries with this query configuration right here. And in fact, there are many examples in their GitHub repo. So this is the official GitHub repository of R2R that I'm looking at. You will find the entire code here, and of course it's completely open source. So just move into these R2R folder and then the example folder, script folder, and here you will find so many examples. Just look into one of them, one of the simpler one, runhide.py. We already discussed that R2R uses an advanced RAG technique called hide or hypothetical document embedding. So this right here is a little example of that. And as we discussed that, hide implements a special technique where instead of embedding the question, it generates a hypothetical answer and embeds that answer. This answer-focused embedding is much more likely to match the relevant chunks you are looking for in your RAG application. And it's like having a magnet, that is the answer embedding that attracts the needles, which is the relevant chunks in the haystack. So imagine you ask a question like, what are the differences between cats and dogs? Instead of searching directly with that question, Hide first uses a LLM, like for example GPT-4, to come up with separate questions about cats and dogs, like what are the characteristics of cats and what are the characteristics of dogs. Then the code searches for information using both of these questions. This way it gets more focused information about each model. And finally, it takes all the information it found and gives it to another LLM, for example, GPT 3.5 or so, to write a clear and complete answer to your original question. So this example code right here is a simple implementation of that. So an initial LLM specified by this part of the code, query transform generation config. So an initial LLM, in this case GPT-4o, transforms the user's query into a set of hypothetical answer or search queries, each representing a possible facet of the user's information need. So basically each hypothetical answer is used as a query to search the vector database. and the search result from each hypothetical answer are combined and fed to another LLM specified by this parameter right here. And in this case, that another model is GPT 3.5 Turbo to generate the final comprehensive answer to the original query. So this complete script is using this module R2R builder to construct an R2R application with a specific pipeline configuration. And this particular module R2R pipe factory with multi-search is crucial here, as it enables the construction of a pipeline that supports the multi-step hide approach. So this factory class here actually enables the encapsulation of the steps of query transformation and multiple searches. And definitely you can look at many more examples right here. So if you just go into another one, Advanced Knowledge Graph Cookbook, there's quite an exhaustive example. Also, you have a sample data ingester for ingesting your data. Yeah, so just go through their examples directory of their GitHub repository to get quite a clear view of the way that you can integrate R2R with your application.